Hey, welcome to Jed Foster Maths. In this video, we're going to be looking at a new integration technique. This is called integration by U-Substitution. Now, this is the second main technique that we're going to be looking at in this series. The first one was integration by parts. And what is integration by U-Substitution? Basically, we can set one variable equal to u, and I'll show you a little bit later in this video how we do this. But when you get an integral that you can't solve with the first two techniques by parts and just with the basic power rule, we can try and use integration by U-Substitution. I'll give you an example. If you were asked to find the integral of tan of x, how would you do this? So I'd say first up we need to write it as the identity. So you know the identity for tan of x is sine x divided by cosine x. So that'd be sine x over cosine of x dx. And as you can see that we have a fraction with two variables that are containing x, and they're both trig functions. So as you can see, there is no simple way to integrate this unless you know the integral of tan x already. But I'm going to show you where it actually comes from. So with U-Substitution, when you encounter a problem that looks like this, what we need to do is we need to define a new variable, u, and we can pick either the top fraction or the bottom fraction, doesn't really matter. But what you will need to do is keep a keen eye out on what we set to u. And essentially with U-Substitution, we're picking a variable, we'll set it to u, then we can differentiate it a bit later, and the aim is to make one of the functions cancel out. And I know this is hard to visualize, so let's start by letting u equal, let's let u equal to cos of x, because it's on the bottom. And I'll show you the reason why, is because when introducing a new variable u, we're going to be writing the new integral in terms of u and not x. So what we need to do next, we need to set du over dx. That's the derivative of u, which is cos of x. And we know cos of x, its derivative is negative sine of x. And as you can see with the original integral, we have dx on the end. And we have du over dx equals negative sine x, because we've took the derivative of u with respect to x. And what we need to do next, we need to solve for dx so we can substitute it back into the original equation. And we can solve dx by, we can bring dx to the other side and then we can divide du by sine x. But I'll write the whole thing out just for the sake of simplicity, and I want you to understand what we're doing. So du equals negative dx sine of x. Then we solve for dx. Dx equals du. So we're going to be divided by sine of x, negative sine of x. Okay, so dx is du over negative sine of x. Write that in a different color. Dx equals du over negative sine of x. Okay, great. So now we've solved for dx. So we've done most of the hard work. What we need to do next is we need to substitute our dx value back into the original equation. And our original equation said that we were finding the integral of sine of x divided by, and remember that we set cos of x equal to u. So we're going to write u down there where the cos of x was, because that's what we've set u equal to. That's what we've defined to find the variable u as. And we've solved for dx, so we're going to be multiplying this fraction by dx, because we know what dx is equal to now by using U-Substitution. So we're going to be multiplying it by negative du over sine of x. And what I want you to pick up is that the sine of x functions are going to cancel out, which means that we no longer are working in terms of x, but we're working in terms of u. And we already know that u is equal to cos of x, but we're working in terms of u to make this an integral that we can actually solve. So now we've cancelled that down, we can simplify it down a little bit more. We're going to have negative 1 over u du. So that's our new integral in terms of u. And as you can see, this is actually an integral that we can solve quite easily. And if you remember from the power rule and your table of integrals, I should say, is that this, a function of u, with a capital F to denote that we're taking the integral, is going to be equal to negative. That's going to be 1 times ln to the absolute value of u plus c, which is just equal to negative ln u plus c. And we've got the answer, but it's in terms of u. What we want to do is have the answer in terms of x. Now, if you recall from the start of the video, we set u is equal to cos of x. So now all we need to do, we need to substitute u back into the equation so we can find the integral in terms of x. So let's do that. We're going to have our integral f of x is going to be equal to negative ln of, and u is equal to cos x, so we're just going to substitute that back into the equation. Cos of x plus c. So that's the answer to the integral of tan of x. And as you can see, this is where it comes from. You could search this up and find the answer quite easily, but this is where it comes from. And integration by U-substitution is so useful because you can solve so many different integrals that you otherwise would have a hard time doing. So let's move on to another example. So let's say you were solving for the integral, let's say sine of x times e to the power of cos of x with respect to x. This is a classic example that we can use U-substitution to solve. Again, what I want you to look at is, you can see e to the power of cos of x. So if we set u equal to cos of x, we know the derivative of cos of x is negative sine x. And what I want you to recognize is that we're going to be dividing by the derivative of whatever we set u to. And if u becomes negative sine x as its derivative, and we're dividing by that, we're going to be able to cancel out a function of x, leaving us with only one function of u, which is what we want because that's easy to solve for. So let's set u to cos of x. So we can say du over dx. So the derivative of u with respect to x is going to be equal to negative sine of x. And dx is going to be equal to du divided by negative sine of x. So now let's rewrite the integral and start adding our terms of u and substituting them back into the original equation. So we're going to have sine of x times e to the u times du divided by negative sine of x. And the sine of x's are going to cancel out, which is what we want because now we're left with one term, and this is in terms of u. And because we only have one function in terms of u, which is our variable, now that's something that we can integrate quite easily. So let's write that down again. We're going to have negative e to the u times du, and when we integrate that, we're going to have a function of u is going to be equal to And we know that any exponential function with the reverse chain rule is just going to be negative e to the u plus c. Technically it's being divided by 1, as that is the derivative of u, which e is to the power 2, but we are not going to write that. And I assume you know this rule already, but if you don't, any exponential, what you're doing with the reverse chain rule to integrate it, you're finding the derivative in the power, and then you're just dividing by the power. So you're dividing by the derivative of the power, and then you're leaving the function as the same, and multiplying it by your division. So we have a function of u is equal to negative e to the power of u plus c. And we want this in terms of x. We've solved it in terms of u, so the last step is to substitute our x value back in, so we have the integral not in terms of u, but in terms of x. So a function of x, let's see, what did we set u equal to? U was equal to cos of x, so we're going to have negative e, substitute u back in, cos of x plus c. So that's integration by U-substitution. So let's work on a few more, alright? Okay, let's say if you were given the integral, and let's change this up a bit. We're going to have a definite integral. We'll have an upper limit of 4, lower limit of 1. We're going to have x minus 1 divided by square root of x dx. And let's work on solving this integral. So I want you to take a look at it and pause the video and write down what you would set u equal to, because that's the most important part of U-substitution, picking your right U-substitution in the beginning, as you can end up with a whole page of work and get nowhere because you simply picked the wrong U-substitution. So pause the video, have a go at this yourself, then come back to the video. Okay, looking at the equation, we can see we have the square root of x minus 1. If we set u equal to the square root, if we set u equal to x, we will be able to cancel out an x on the top, and that might work. If we set u equal to the square root of x, we could solve for x, and I'll show you this technique. So if we set u equal to square root of x, and because as you can see we're not going to be able to cancel the x out, what we can do, we can solve for x is going to be equal to u squared, because we're taking the square root of both sides. So if we know that, we can write the integral down again, and we'll substitute both these values in. So this is what u is, and we also know what x is equal to. So if we know x is equal to u squared, we can write it down as u squared minus 1 divided by, and u is equal to the square root of x, so just u, 4, and that's our limits. And again, as you can see with the fraction, we can split it up. So we can have u squared divided by u minus 1 on u du. By the way, what I want you to remember as well, and I'll show you this, is when you're working with definite integrals with U-substitution, because we're adding a new variable u into the equation, our boundaries are going to be slightly different, or quite a bit different. So we need to solve for our new boundaries. In terms of x, we have our boundaries are equal to 4 and 1, but we want this entire integral in terms of u. So if we know u is equal to the square root of x, let's solve for our new boundaries. We're going to have u, so we're going to know our top limits in terms of u. Our upper limit is going to be equal to the square root of 4. And our lower limit is going to be equal to the square root of 1. And this is because we've set u equal to the square root of x. And when you're finding your new limits in terms of u, you simply just substitute your boundaries with what you set u equal to. So if you had u equal to cos of x, your upper limit is going to be equal to cos of 4. So that's the idea. So let's solve that. That is going to be 2 and 1. And let's rewrite the integral. Have it's going to be equal to 2 and 1. We're going to have u minus 1 over u du. Let's solve our integral in terms of u. We're going to have a function of u. It's going to be equal to, it's going to be u squared divided by 2 minus natural log of u c. And for this example, we're not actually going to substitute x back in because we've already found what our new limits are in terms of u. So we're going to get the same answer. So let's substitute our limits into this definite integral. And this is the exact same process as your normal definite integration. So what you're going to do first, I'm going to chuck some brackets in there. We're going to have our limits 2 and 1. We're going to have 2 squared divided by 2. So just substituting the limits into the equation minus natural log of 2. Then we're going to be taking away 1 squared divided by 2 minus natural log of 1. And I'll chuck that into the calculator real quick and let's see what we get. So that's going to equal about minus 2 ln of 2 plus 3 all divided by 2 units squared, which is approximately 0.8 units squared. Okay, so let's move on to another example. Let's look at this question here. So if we were asked to solve for the integral of e to the root x divided by square root of x dx, let's say we were asked to solve this integral using integration by U-Substitution. So let's have a look at the problem. We have the square root of x and we also have the square root of x. And let's think about how we can actually solve this. So we want to pick our u variable first. So that's the most important step to this problem. So let's think about what we can set u equal to. We can either set u equal to x or u equal to the square root of x. I want you to pause the video and give this a go. Pick your U-Substitution and see if you get it right. Okay, let's have a look at this problem. Let's think about what we're going to be setting u equal to. Let's say we let u equal, let's say we let u equal the square root of e to the square root of x. Okay, I think that's what we're going to do. So let's work on solving this. So we're going to find the derivative of this function. That's going to be 1 divided by 2. So let's solve this. The derivative of the square root of x is going to be a half times x to the negative a half. So du over dx equals, that's going to be a half times x to the negative a half e to the root x, which is going to equal 1 over 2 root x. And we know that u equals e to the root of x, so we're going to have just u. And let's solve for dx. Dx is going to be equal to, that's going to be 2 root x du all divided by u. And pretty much what we did, we brought the dx over to this side, then we divided. We did du divided by 1 divided, that would be u divided by 2 root x to solve for dx. So cross multiply 2 root x du divided by u. So that's where we got that answer from. Alright, let's substitute this back into the equation and write this down in terms of u. So we're going to have u divided by root x times by dx. And we know that dx is equal to 2 root x du over u. And you can see that the root x is going to cancel out. The u's are going to cancel out, leaving us with an integral of 2 du. And let's solve this in terms of u. It's going to be equal to 2u plus c. And let's substitute our x values back in. We know u equals e to the square root of x. So that's going to be 2 times e to the square root of x plus c. And that should be the answer to this question. I know this was a bit more of a tricky question, but we solved it. And it's all about picking and choosing what you're setting your u variable equal to. So let's work on one more question and then we're going to wrap the video up. Okay, this is a good one. So let's say we were asked to find the integral of e to the power of the square root of 3x plus 9 dx. Alright, this one we're going to have to think about. So, we need to set u. And again, pause the video, give this one a go, and then come back. So let's set u equal to, what can we set u equal to? I reckon let's try setting u equal to the square root of 3x plus 9, which means when we take the derivative with respect to x, we're going to have, using the chain rule, we're going to have a half times 3 multiplied by 3x plus 9 negative a half, which is going to be equal to 3 divided by 2 to the square root of 3x plus 9. We solve for dx by dividing by du. I'm going to have 2 root 3x plus 9 du. I have got 2 divided by 3. It's going to be multiplied by that in terms of u. Sorry, 2 divided by 3. And that is our du value. And as you can see, we want to cancel out our x values. So let's go back to the original u equation and solve for x. X is going to be equal to u squared minus 9 divided by 3, because we're taking the square root of both sides, minus 9. Then we're dividing by 3. And that's how we're solving for x. So we know x is equal to u squared minus 9 divided by 3. And I think that's going to be very important in the next few steps. So let's write the integral out again. We're going to have the integral of e to the u multiplied by dx. That's going to be 2 over 3x plus 9 du. But we still have a term of x in here, which we do not want. We want this in terms of u. That's why we just solved for x, so we can then write this in terms of u. So let's substitute our x value in to this x value here. We're going to have e to the u times 2 divided by 3. That's going to be 3. And we're multiplying it by u squared minus 9 divided by 3 plus 9 du. And let's look at this. We can see we can cancel out the 3's and we can cancel out the 9's, so that we can cancel out the u squared as well. I'll write it all out though. So we're going to have e to the u times 2 divided by 3. So our 3's are going to cancel out. We're going to have u squared minus 9 plus 9 du. 9's cancel out. And because we have a square root inside and it's being squared, we can cancel that out as well. Which is going to leave us with the integral of, so we're finding the integral of e to the u 2 divided by 3 u du. That's going to equal 2 on 3 u e to the u. And we're nearly at a stage where we can solve this, but we're left with two functions that are containing u. So as you recall from the previous video on integration by parts, we're going to need to use that to solve this. And if you don't know integration by parts, make sure you watch the previous video because we're going to be using that to solve this. So make sure you know integration by parts before continuing with the video. So we've used integration by U-substitution to form the integral in terms of u to something that we can solve. But we're still going to need to use integration by parts to solve this integral just because it's a bit more tricky. So integration by parts, we're going to do it by the table method. We're going to have our derivative d integral I. And remember to add plus, minus, plus, and just have them oscillating down. So let's find the derivative of 2 on 3 u e to the u. When we integrate e to the u, again we just get e to the u. When we find the derivative of 2 divided by 3 times u is just 2 on 3. We're left with a row that only contains one function of u, which means that we're going to be able to find the integral of this row, which is one of the 3 stops that we need to do. So again, let's start to solve this integral. So we're going to have integral is going to be equal to e to the u times 2 divided by 3 u and minus the integral of 2 divided by 3 e to the u du. That's going to be equal to e times 2 on 3 u. When we solve this integral, we're going to have minus 2 divided by 3. That's going to be multiplied by 2. So that's just going to be 2 divided by 3 divided by 1, times 1, e to the u plus c. And again, we don't need to write the times 1. That's just the reverse chain rule for the exponential function. So that's our integral, but we can simplify this down a bit. So still in terms of u, it's going to be equal to, sorry, I forgot to write e to the u. We can factor out e to the u. We can also factor out 2 divided by 3. So that's going to be e to the u. So that's going to be 2 divided by 3 e to the u. That's going to be multiplied by u minus 1 plus c. So that's our integral. All we've done, we've factored out some of the things that we could simplify this down to. This should be the most simple form. So let's write this in terms of x. What did we set x equal to? Great, we set u equal to the square root of 3x plus 9. So we're going to substitute that back into the equation. 2 divided by 3, e to the square root of 3x plus 9 multiplied by 3x plus 9 minus 1 plus c. So that's the final question, and thanks so much for watching the video, guys. I hope you learned that you can now do integration by U-Substitution. And as you can see, it's a very fascinating method to integration, and you can solve many things by using this method. So thank you so much for watching, and always remember that Jesus loves you, and I love you too. I'll see you in the next video. Bye.